Welcome to Learn Yourself. Today we are going to learn and understand in-text question from the page number 106. This is under CBSE Standard 9 syllabus. So first question is, if action is always equal to the reaction, explain how a horse can pull a cart. So in this situation, when actually is happening, so when horse is moving, how much amount of force horse is applying on the ground, that much amount of force it gets back from the ground as a reaction force, and so it will be able to move forward in the direction, and because it is pulling the cart will along with it, so horse will apply greater force on the ground, and as a reaction horse will get a greater force as its reaction. So as the horse is moving forward, it will be able to pull the cart along with it. So how we will write this? When the horse walks in the forward direction, it applies force on the ground in the backward direction. So like this, when it is going in forward direction, it is applying force in backward direction. So as a reaction force, it will get exactly the same amount of force back, but it will be in the opposite direction. Action and repulsive forces are equal and opposite in direction as per the first law of motion. So the exact amount of force it will get it back and it will move forward because it is in the opposite direction. The equal amount of force will be applied to horse from the ground, which is in opposite direction, as a reaction force or as a repulsive force. And due to this force, horse moves forward and pull the cart. Second question is, explain why it is difficult for a fireman to hold a hose which ejects large amount of water at high velocity. So imagine a fireman is holding a hose, and once he starts the water, a large amount of water is coming out with high velocity because water has to reach at the top or wherever the fire is there. So large amount of water will come out with high velocity. With how much force the water is coming out, the velocity and amount of water, that mass of water will have some momentum. So with how much momentum it comes out, that much momentum or that much backward reaction force will be applicable to fireman as per the third law of motion. So how much amount of momentum the water will gain, that much amount of reaction force will be applicable to fireman. So this situation will be difficult to handle for the fireman because he has to remain sturdy on the ground, and whatever reaction force is applicable on him, he has to be sturdy against that force and he has to hold the hose in his hand. So how we will write this answer? That when fireman starts water, large quantity of water will comes out with high velocity. The reaction force of this, so this is important, so the reaction force of this will be applied to fireman and it will be in opposite direction, and that too in opposite direction. So it will be difficult for fireman to maintain balance and remain sturdy on the ground as the force will push him backward because it is in the opposite direction. As water will go in forward direction, the reaction force will be in backward direction. So he may fall backward if he will not remain stable or sturdy on the ground. So answer is, the reaction force of this will be applied to fireman and that too in opposite direction. So it will be difficult for him to remain sturdy or stable on the ground. Our third question is, from a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. So as per the third law of motion, we will first find out that before fire what is the momentum and after fire what is the momentum. Then we will compare these two situations as these two situation will be equal as per the law of conservation of momentum, and then we will get the initial recoil velocity of the rifle. So at first stage, when the bullet is along with the rifle before fire. So first let us note down all the details what all given to us, that M1 is equals to 4 kg, the mass of rifle. Then the mass, that is M2, that is 50 gram of bullet. Now when it is fired, the initial velocity of the bullet is 35 meter per second, but that is after firing. That is after firing. So here I am writing V equals to 35 meter per second, and that is for the bullet. That is for the bullet. Now what will be the initial velocity of this two when rifle and bullet is at the steady position, at the resting position before fire? So U1 and U2, for both of this will be 0, because before fire they both are at the steady position, at resting position. So U1 and U2 will be 0. Here V2 they have given, and we have to find out V1, that is recoil velocity of the pistol, recoil velocity of the rifle, that we have to find out, and V2 they have already given. And initial velocity of both of this rifle and bullet will be 0, because they are at the steady position or resting position. So here we are going to compare these two situations, that before fire and after fire. From the law of conservation of mass, these two terms are going to equal. Once we will compare that, we will get this recoil velocity of rifle. Now first situation, that is before fire. So before fire we are going to get M1 U1 plus M2 U2. So here when we are multiplying the mass, that is 4 into 0 plus 50 into 0. Here both of this are at resting position. So U1 equals to U2 equals to U, that U also you can write 0. Here M1 you can also write like M1 plus M2 out of the bracket U, which is going to be 0. So in turn this before fire momentum is going to be 0. Now let us find out after fire. So after fire momentum is M1 V1 plus M2 V2. We know the mass, that 4 into V1 is, here we are going to write V1, we do not know, we need to find out the velocity, recoil velocity of rifle. Then M2 is 50 gram. Here we are taking mass in kg, because we are finding momentum. So appropriate unit for mass is kg. So here 50 gram is there, we need to convert it into kg. So from smaller unit to bigger unit when we are going, we need to divide. So here we need to divide with 1000. So gram, we are converting it into kg. So we are going to divide with 1000. So 50 is there, 50 divided by 1000, we will get here 0.05 kg. So this gram we have converted into kg. Now this kg we are going to use here. That 0.05 into, what is our V2? V2 is 35. V2 is 35. Now this is the term what we got as a momentum after fire. Now this term and this term is going to be equal as per the law of conservation of momentum, or as per the third law of motion. So here we are going to write as per the law of conservation of momentum. So here 4V1 plus, when we will multiply this, we will get 1.75. As an answer of this multiplication we will get 1.75 equals to final momentum equals to initial momentum, after fire equals to before fire. So this term equals to 0 we will get here. So 4V plus 1.75 equals to 0. So let us V1 equals to 1.75 and in the denominator 4 will be there, because here 1.75 is in the plus. Once it is changing the sign, it will get negative sign, and this is in the multiplication. Once it is changing the side, it will go to denominator. So once we will solve this, that 1.75 in denominator 4, we will get 0.4375, and this is going to be negative. This is going to be negative, and since this is velocity, the unit it is meter per second. Meter per second. Now this is negative. That means it will go in backward direction. It will go in backward direction. So when we are writing the answer, we will write that recoil velocity of the rifle will be 0.4375 meter per second, and it will be in the opposite direction of the fire, or it will be in the backward direction of the fire, since this is negative. So fire is in a forward direction and rifle will move backward because this is negative. Our fourth question is, two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocity of 2 meter per second and 1 meter per second respectively. They collide, and after the collision, the first object moves at a velocity of this much. Determine the velocity of the second object. So here what they are asking us, that this is object 1. This is object 1 with M1, and this is object 2 with M2. They both are moving in the same direction. Like this, they both are moving and they are having certain velocity, that is u1 and u2. They are having certain velocity. Now after this, they are colliding with each other. They are colliding with each other, and after this they will separate. They will separate, and the first object will move away with certain velocity that they have given us. So this object will have how much velocity after collision? So they are moving, their velocity and masses we know. After collision, one object will move with certain velocity. So another object will move with how much velocity, that we have to find out. So we are going to solve this numerical as per the law of conservation of mass, that is third law of motion. Before collision we will get one term, and after collision we will get one term. So before and after collision, when we are writing those two terms in equals to with each other, we are going to find out, and we will be able to get the velocity for the second object. Let us first note down all the details what all they have given to us. So two objects of masses 100 gram and 200 gram. So I am going to write here M1 equals to 100 gram and M2 equals to 200 gram. Are moving along the same line with velocity. So they already possesses some velocity. So u1 and u2. So u1 is 2 meter per second because they already have this velocity, and u2 is going to be 1 meter per second. Now after collision, the first object move at a velocity of 1.67. So that is going to be final velocity. So I am going to write here v1. v1 is 1.67 meter per second. v1 is 1.67 meter per second. This is the final velocity of first object, and we have to find out the final velocity of second object, that we have to find out. Now here mass they have given is in grams. We need to write them, or we need to convert them in kg. So 100 gram we need to convert it into kg. So when we are going from smaller unit to bigger unit, we need to divide with 1000. So 100 divided by 1000, we will get this 0 will get cut, and then we will get 0.1 kg. And similarly, when we are converting this 200 gram into kg, we will get 0.2 kg. So here this is going to be 0.1 kg, and this is going to be 0.2 kg. Now we are going to use this mass in our formula. So here we are writing before collision. So before collision we will get m1u1 plus m2u2. So m1 is 0.1 into its velocity is 2, whereas m2 is 0.2 and its velocity is 1. So from this we are going to get 0.2 plus 0.2, we will get 0.4 kg meter per second. This is the momentum before collision. Now let us consider the situation when they collide. So this is after collision. So this is after collision and our formula is m1v1 plus m2v2. So m1 we are going to write here 0.1 and its velocity they have already given, that is 1.67. So 1.67 plus m2 we know that it is 0.2 and v2 we have to find out. Now this is our second term. So as per the law of conservation of mass, this term and this term are going to equal. So this term equals to this term and from that we are going to find out v. As per the law of conservation of momentum, before collision equals to after collision. So here before collision's answer was 0.4 and this term we got it from after collision. So here let us solve this. So here we will get 1.67 into 0.1. So we are going to get here 0.167 plus 0.2 into V2. So let us take this term this side. So we will get here 0.4 minus 0.167 equals to 0.2 V2. So here we are going to get answer 0.233 from the subtraction of this term, and that too in division 0.2, as this 0.2 will come towards this side. So this is going to be our V2. Now as an answer of this term we are going to get V2 equals to 1.165 and that too is positive. Since this is velocity, the unit of velocity is meter per second. So this is our answer, that this much will be the velocity for the second object. The final velocity of the object is 1.165 meter per second. So hope this video has solved your doubt. In coming videos we are going to understand many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.